Welcome to our channel Electron Chemistry Tutorial. I am Vijayalaxmi. Now let us discuss objective bits from atomic structure. First of all, let's see some important points from atomic structure. Okay, let's start. So, a neutral atom except hydrogen has electron, proton, neutrons. Clear? So then these electron, proton, neutrons are called subatomic particles. Subatomic particles. Okay. So the subatomic particles also called as fundamental particles because of these electron, protons, neutrons are main constituents in all atoms. Okay, that's why they are called fundamental particles. Okay. So let's see some important properties of electrons, protons, neutrons. So electron was discovered by J.J. Thomson, proton was discovered by Rutherford, neutron was discovered by James Chadwick. Next, nature of electron negatively charged, protons positively charged, but neutron is neutral. Next, relative charge. Relative charge of electron taken as -1, here +1, here charge is neutral, no? So that's why 0. Next, absolute charge. For one electron charge 1.602 in 10 power minus 19 coulombs or -4.802 into 10 power minus 10 electrostatic units. Electrostatic units. Okay. So same value but signs are different. So here negative sign, here positive sign. Simply you can take plus 1.602 10 power minus 19 coulombs, here plus 4.802 into 10 power minus 10 ESU, electrostatic units. So charge always 0. Okay. Next, relative mass for electron 0.00055 atomic mass units. So here 1.007276 atomic mass units for proton. For neutron 1.008665 atomic mass units. So neutron mass is slightly heavier than proton. Okay. So keep it in mind. Absolute mass of electron 9 into 10 power minus 31 kgs. So here proton 1.673 10 power minus 27 kgs, 1.675 10 power minus 27 kgs. Clear? So then simply atom of the element can be represented by X superscript A and subscript Z on the left hand side. Okay. X means symbol of that element. Symbol of that element. A means mass number of that element. Z means atomic number of that elements. Atomic number of that element. Okay. So simply how to define atomic number Z? See here, atomic number Z is denoted as simply number of protons or electrons in the neutral atom. Neutral atom, simply known as atomic number Z, or simply the serial number of element in the modern or long form of periodic table. Okay, the serial number of that element in the long form of periodic table is said to be atomic number of that element Z. Okay, or simply number of protons in the nucleus or number of electrons in the extranuclear part of that atom, neutral atom, not that ions. Okay. Next, mass number, simply sum of the protons and neutrons present in the nucleus. Neutron number, the difference between mass number and atomic number is also known as neutron number. Neutron number. Clear? Isotopes nothing but atom of the same element. Here atoms of carbon element. So have a same atomic number but different mass numbers are called isotopes. Okay. Same atomic number but different mass numbers. So atom of the same element nitrogen, same atomic number 77, 14, 15 mass numbers. So then simply you can take isobars. Iso means same, bar means mass. Okay. So simply atom of the different elements, carbon element, atom of carbon, atom of nitrogen. Atom of the different elements have same mass number but different atomic numbers. Different atomic number. This is common, not 17. Okay. Next here same argon, potassium, calcium all are have same mass 40. So they are simply isobars. Next isotones. Isotones nothing but have same neutron number. Neutron number. Suppose for example here 23 minus 11, how much? 12. So here 24 minus 12, how much? 12. Okay. Simply both these atoms have both sodium 23, magnesium 24 have same neutron number, that's why they are isotones. Iso means same, tones means neutrons. Okay. Next atom of the different elements have same neutron number are called isotones. Clear? So let's see some objective bits on this topic. Clear? Yeah, simple problems. How many protons, electrons and neutrons are present in an atom of C612? Carbon 612. Okay. See here, how to find that simple, this is what atom of that element. What is atomic number? Z is equals to how much? 6. So atomic number nothing but what is that? Proton number or electron number in that neutral atom. This is carbon neutral atom. No, there is no ion here. How many protons? 6. How many electrons? 6. So then what is the mass number? 12. How many neutrons? Neutrons means the difference between mass number and atomic number. So mass number and atomic number. Mass number 12 minus 6. How much? 6. So simply electron 6, proton 6, electron 6 and neutrons also 6. Okay. Simply you can find out like this. Okay. So next, how many protons, electrons, neutrons are present in an atom of nitrogen 15 isotope? Simply nitrogen 15 isotope nothing but here. So write down atomic number nothing but 7. So that is neutral atom, that's why, so that 7 is equals to proton number and also equals to electron number. So then a mass number 15. So neutron number A minus Z is nothing but 15. A means 15, Z means 7. How much? How much? 8. So neutron number 8. Simply, so proton 7, electron 7, neutrons are 8. Okay. So you have to select proton 7, electron 7, neutrons 8. So 7, 7, 8 option is correct. Okay. Next. Listen to me carefully here. How many electrons, protons, neutrons are there in an ion of Cl minus 37? Cl minus 37, this is ion. So means C17 atomic number, mass number 37. First of all write down atomic number, mass number 17. So that is equals to always protons present in the nucleus. Okay. So then mass number 37. Okay. Now electron. Electron number here. So how many electrons in the neutral atom of chlorine 17? Actually in neutral atom 17 electrons are present. So minus means it add one more electron. It added one more electron means 17 plus 1. How many electrons? 18 electrons. Okay. So negative charge means it's already added one electron. So already 17 electrons are present in neutral atom. Added one more electron means 17 plus 1 is equals to 18 electrons. Clear? So the next neutron number A minus Z means 37 minus 17. How much? How much? 20. Clear? So this is what simply number of electrons, protons, number of protons 17, electrons 18, neutrons 20 in Cl minus ion. Clear? Next, how many protons, electrons, neutrons are present in an ion of Zn plus 2? Mass is given as 65 in the bracket. Okay. So simply how to write element Zn plus 2. So what is the atomic number of zinc? 30. Okay. So mass is given as 65. Okay. Now, so find out atomic number Z30, that is equals to proton number. So simply mass number 65, neutron number A minus Z, nothing but 65 minus what? 30. So how much? 35. Okay. So neutrons 35, protons 30. So how many electrons? Electrons nothing but how many electrons? Electrons is equals to mass, proton number. Electrons is equals to proton number in the neutral atom, and so zinc lost 2 electrons, it loses 2 electrons. So 30 minus 2, how many electrons? 28 electrons are present in the dipositive zinc ion. Okay. So this is what simply how many protons? 30. How many electrons? 28. How many neutrons? 35 in the dipositive zinc ion. Okay. So this question also is given as simply find out the electron number or a neutron number in a dipositive zinc ion. Dipositive zinc ion. Also same. So next, how many electrons, protons, neutrons are present in the following atoms? So 6, 13 isotope, calcium 40, so bromine 80. Okay. So simply you have to find out electrons, protons, neutrons. So in the atom of the element. You have to do it, ma. Okay. Let's go for next topic. Next topic. Electromagnetic radiation. So electromagnetic radiations are energy waves. Energy waves, they contains both electric and magnetic vectors perpendicular to each other. Electric and magnetic vectors perpendicular to each other. Suppose this is electric field. So this is magnetic field. They are perpendicular to each other. Unlike sound waves, they don't need any medium to propagate. Okay, they propagate even in vacuum. Clear? Next, characteristics properties of electromagnetic radiations. Wavelength denoted as lambda. So this lambda is denoted as simply the distance between two successive crests or two successive troughs is known as wavelength. Okay, units are meters, centimeters, meters, angstroms, nanometers, picometers, micron. Okay. So then simply here, suppose 1 angstrom you can take 10 power minus 10 meters or 10 power minus 8 centimeters. 1 nanometer you can take 10 power minus 9 meters or 10 power minus 7 centimeter, that is equals to 10 angstroms. So remember this. So next 1 nanometer is equals to over the 1 picometer is equals to 10 power minus 12 meters or 10 power minus 10 centimeters. Okay. So then next 1 micron is equals to 10 power minus 6 meters or 10 power minus 4 centimeters. Clear? So remember this table. Okay. So it is very useful to our calculations. Okay. So the next velocity. No. Frequency. Frequency is nothing but the number of waves that can be passed through a given point in 1 second. In 1 second, how many waves pass through a given point is nothing but simply frequency. So frequency is related to the wavelength, that is c by lambda. So c means velocity of that light. Velocity of light nothing but the distance travelled by a wave. The distance travelled by a wave in 1 second. 1 second is known as velocity of that light. Okay. Units for frequency. Units for frequency what? Second inverse. Second inverse or hertz. Next velocity. Velocity units. Distance travelled by wave, simply meters per second or centimeters per second. Okay. So this is frequency units. Next wave number. Wave number is nothing but reciprocal of that wavelength. Reciprocal of that wavelength nothing but simply here 1 by lambda. Or simply number of waves that can be present in a unit length. Suppose you can take 1 meter length. How many waves are present in 1 meter length? That is wave number. So that is simply reciprocal of wavelength. Okay. Next, so this wave number units. So 1 by lambda nothing but lambda meter centimeters nothing but the inverse means in centimeter inverse, meter inverse, angstrom inverse, nanometer inverse. These are units. Okay. Next, energy. Energy is proportional to its frequency. According to Planck's, the energy of light, emitted energy or absorbed energy in the form of small packets called quanta. This quanta of visible light is also known as photons. Photons, not protons. So this is nothing but proportionally constant h. So h is equals to Planck's constants. This Planck constant value 6.626 10 power minus 34 joule second or 6.626 into 10 power minus 27 arg second. Clear? Next, amplitude. Amplitude is nothing but the height of the crest or depth of the trough is said to be amplitude of that wave. So this amplitude of that wave determines the strength of that light or intensity of that light or brightness of the light. Clear? So it is independent property, now depends on the remaining properties. So there is no units for that amplitude. Clear? So next, photoelectric effect. So photoelectric effect, how to define simply? The ejection of electrons, a removal of electrons from metal surface when suitable frequency of light fall on it or strikes on it. So that is photoelectric effect. Okay. In vacuum chamber, so if suitable frequency of light fall on the metal surface, then that metal can eject electrons, can remove electron. That phenomenon is known as simply photoelectric effect. Okay. Only few metals with low ionization potential shows photoelectric effect because of the metals loosely held electrons with nucleus. So thus the loosely bounded electrons easily can be removed by that metal. Hence, so that is photoelectric effect. Okay. So this photoelectric effect, suppose suitable frequency, suitable energy of light fall on the metal surface. Some of its energy used for the eject electron, that is what threshold energy. Threshold energy. Remaining energy is given to the eject electrons as kinetic energy. As kinetic energy. Okay. So what I am trying to say here, suppose 100 joules per mole energy strikes on the metal surface. Some of its energy nothing but suppose 30 joules per mole. 30 joules per mole is used for the eject electrons. So that is not threshold energy not. Okay. So remaining energy is given to the eject electrons as kinetic energy, or imported to the eject electrons as kinetic energy. So remaining energy nothing but 70 kilojoules, 70 joules per mole energy given to the eject electrons as kinetic energy. Clear? So simply this formula is nothing but h nu by A Planck's formula. So E naught nothing but h nu naught Ke. Okay. Suppose you want to find out Ke, simply h nu minus h nu naught. So you can take h common, nu naught. Clear? So these are possible formulas. So this is first formula, second formula, third formula. Okay. Next fourth formula. So simply here h nu naught Ke nothing but we know very well half mv square. Half mv square. So these are possible formulas for photoelectric effect. Okay. Now one more point here. If here 100 joules per mole energy strikes on the metal surface, so some of its energy used to the eject electrons, that is threshold energy. So remaining energy is converted as kinetic energy. Okay. If incident light is doubled, suppose 200, threshold energy remains constant for given metal, so that is 30 only. But here how much? 170. If incident light is doubled, kinetic energy is more than doubled. So 70 is double nothing but 140 only, but 170 is more than doubled. If incident light is doubled, kinetic energy is more than doubled because threshold energy remains constant for given metal. Okay. So this is what photoelectric effect. Let's do some objective weights on this topic. Okay. Let's go. See ya. Simple problems. Sixth problem. The wavelength of a radiation emitted by a sodium lamp is 200 angstroms. Find the frequency. So we have to find out frequency. Wavelength lambda is given as 200 angstroms, that is nothing but 200 into 10 power minus 10 meters. So what is the relation between them? Frequency is equals to c by lambda. For that c, velocity of light always constant, so that is what? 3 into 10 power 8 meters per second. So velocity of light always constant, that is what? 3 into 10 power 8 meters per second, or 3 into 10 power 10 centimeters per second. Okay. Now substitute this values. Mu is equals to c value 3 into 10 power 8 meters per second. We have to remember this. So lambda is given as 200 means 2 into 10 square into 10 power minus 10. Okay. Now 3 by 2, here 10 power minus 8 will become 10 power plus 8, 10 power 16, 8 plus 8. 1 is 1.5 into 10 power 16, what? Second inverse or hedges. Clear? Now next problem. The frequency of the radiation having wave number 100 meter inverse. 100 meter inverse. So frequency, we have to find out frequency here. So wave number given as 100 meter inverse. So what is the relation between them? Simply write down this formula. Mu is equals to c by lambda, but c into 1 by lambda. This is also written as c into 1 by lambda. Reciprocal of wavelength is nothing but wave number, no? So that is why frequency is equals to c into wave number. C means always constant, that is velocity of light 3 into 10 power 8 meters per second. So wave number is given as 100 meter inverse. Then how much? 3 into 10 power 10. 10 means 10 square, no? So 2 plus 8, 10. So second inverse. Okay. Next. The energy of photon of radiation having wavelength 3 nanometers. Wavelength is given as 3 nanometers. 1 nanometer is equals to how many meters? 10 power minus 9 meters. So simply 3 into 10 power 9 meters. Okay. So then formula of energy is nothing but E is nothing but H nu, that is equals to E is equals to nu means C by lambda. C by lambda. Okay. So now here H value we can take in as 6.626 10 power minus 34 joule second. C value 3 into 10 power 8 meters per second. So lambda is given as 3 into 10 power minus 9 meters. So all values substituted here. E is equals to 6.626 10 power minus 34 into 3 into 10 power 8 meters per second. Lambda. How much? 3 into 10 power minus 9. 3 mutually cancelled. 6.626 into 10 power minus 34 into 10 power 8. 10 power minus 9 will become plus 9. So how much? Simply minus 17 watt joules per mole. Okay, clear? Next, the number of photons of light having wavelength of 1 angstrom which can provide 1 joule energy is nearly. Simply, energy of one atom, we know very well that is equals to H nu. So it's nothing but E is equal to C by lambda. Okay. H 6.625 or 6 10 power minus 34 joule second, 3 into 10 power 8 meters per second of velocity of light. Lambda is given as 1 angstrom. 1 angstrom nothing but 10 power minus 10 meters. 10 power minus 10 meters. 19.878 into 10 power minus 16. One atom produces or provide 19.878 into 10 power minus 16 joules energy. 1 joule energy is provided by how many atoms? Simply 1 atom, 1 into 1 by 19.878 10 power minus 16. Okay. Then how much? Into 10 power 16. Nothing but 5 into 10 power 14 what? Atoms. Clear? Next. The atomic transition gives rise to the radiation of frequency 100 Hz. The change in energy per mole of atoms taking place would be. See here, energy of one atom. Energy of one atom is equals to H nu. H nothing but 6.626 10 power minus 34 joule second. So mu is given as 100 Hz, 10 square. How much? 6.626 10 power minus 32 only. Okay. Now, one atom, energy of one atom, energy of one atom is how much? Calculated as 6.626 10 power minus 32. Energy of 1 mole of atoms. 1 mole of atoms nothing but 6.023 10 power 23 Avogadro number of atoms, capital N, has how much energy? Simply here multiply these two, will get answer. That is equals to 6.023 into 10 power 23 into 6.626 into 10 power minus 32. How much? 39.9 into 10 power minus 9. Okay. Next. These two problems homework for you. Very simple problems. I will give you a hint. Okay. So you have to do and write the answer in the chat box. Clear? So here find the energy of photons which corresponds to light of frequency 3 into 10 power 12. So you have to find out energy. So frequency is given. Okay, how much? 3 into 10 power 12 hertz. So what is the relation? E is equals to h nu only. We know very well h value, and that h values are multiplied with the frequency. Okay, clear. Next, the wavelength of blue light, lambda is given as 4800 angstroms. Calculate the wave number. So what is the relation? Wave number is equals to 1 by lambda only. So lambda is given. So you have to calculate and write the answer in the chat box. Okay, have to do it. Okay. Next problem. The threshold frequency for a metal is find 10 power 14 second inverse. Calculate the kinetic energy of an electron emitted when radiation of frequency 10 power 15 second inverse hits the metal. Simply, what is this threshold frequency is given? How much? 5 into 10 power 14 second inverse. Incident frequency mu is equals to 10 power 15 second inverse. Calculate the kinetic energy. So what is the relation between them? So simply this is what photoelectric effect. Okay. So simply E is equals to E naught plus Ke. E is nothing but h nu is equals to h nu naught plus Ke. So we have to use this formula because of frequencies are there in the question. Okay, kinetic energy is equals to h nu minus h nu naught. So you take h common. So nu minus nu naught. Nu is given as how much? So h value we know very well, 6.626 into 10 power minus 34 joule second. U is given as 10 power 15 minus 5 into 10 power 14. Simple problem. 6.626 into 10 power minus 34 joule second. So this is simply written as how much? 10 into 10 power 14 minus 5 into 10 power 14. 6.626 into 10 power minus 34, 10 minus 5 into 10 power 14 will be common. 6.626 into 10 power minus 34 into 5 into 10 power how much? 14. By multiplying this 33.130 into 10 power minus 20 kinetic energy. Okay. Next problem. So this is previous bit. So it is present in 2019 JEE mains paper. So what is the work function of metal if the light of wavelength 4000 angstroms generates photoelectrons of velocity 6 into 10 power 5 meters per second from it? So the mass of electron is given as 9 into 10 power minus 31 kgs. So velocity of light is given as 3 into 10 power 8 meters per second. H Planck's constant value also given 6.626 10 power minus 34 joules second. Okay. So your energy, incident energy is equals to threshold energy plus kinetic energy. So this threshold energy is also known as work function W. Work function. Because these energies are used to eject electrons, so used to some work, so that's why work function. Okay, so we have to calculate this work function. So simply work function is equals to E is minus kinetic energy. Okay, but we know very well E is equals to, capital E is equals to what? Wavelength is given. What is the relation between the energy and wavelength? hc by lambda. Okay. So now first of all we have to calculate E, then we have to calculate Ke, then finally we will get the work function. Okay. So Planck's constant value 6.626 10 power minus 34 joules second. So velocity of light is given as 3 into 10 power 8 meters per second. So lambda is given as 4000. 1 angstrom is equals to 10 power minus 10 meters per second. Sorry, meters. Okay. Now by simplifying this we will get 4.96 into 10 power minus 19. This is what E value. Next, kinetic energy. Kinetic energy is velocity is given nothing but half mv square. Half into mass of electron is given as 9 into 10 power minus 31 kgs. V 6 into 10 power 5 whole square. Okay. Simply 1 by 2, 9 into 10 power minus 31, 6 6 are 36 into 10 power 10. By simplifying this, 1.62 into 10 power minus 19. This is what Ke. Now, work function is equals to E minus what? Ke. E value 4.96 into 10 power minus 19 minus 1.62 into 10 power minus 19. So, we will get 3.34 into 10 power minus 19. Work function is calculated as 3.34 into 10 power minus 19 joules. But all options are given in electron volts only. For that, so this joules value can be converted into electron volts. For that, 1 joule is equals to 6.242 into 10 power 18 electron volts. So 3.34 into 10 power minus 19 joules is equals to how many electron volts? Okay. Simply 3.34 into 10 power minus 19 into 6.242 into 10 power 18 electron volts. By multiplying these two, we will get 20.8 into 10 power minus 1. So that is equal simply 2.1 in electron volts. So this is the answer. Clear? Next. This is also previous bit 2019. if P is the momentum of the fastest electron ejected from the metal surface after the irradiation of light having wavelength lambda. Then for 1.5 p momentum of the photoelectron, the wavelength of the light should be. Here, assume kinetic energy of eject electron to be very high when compared with work function. Okay, here E is equals to work function plus Ke, no? Okay, so this kinetic energy very high when compared with work function, means this work function very less. So that's why you have to ignore this work function. You have to ignore. Okay, simply you can take E is equals to Ke only. Okay, see here, E is nothing but, see here, E is nothing but Hc by lambda. For two conditions, simply here you can take Hc by lambda, then Hc by lambda 2. Okay, next kinetic energy also. Kinetic energy is nothing but half mv square. Okay, so then here momentum is nothing but product of mass and velocity of light. So simply we square, you can take square. So instead of here v square, nothing but p square by m square. So this instead of v square you have to substitute this value. K is equals to half m into p square by m square. Finally half p square by m only. Okay, see here. So this is what for first condition Ke1. For second condition Ke2, if momentum of that fastest electron lambda 1 p, so then the 1.5 p, so means for second condition momentum 1.5 p means square by 2m. Okay, E1, E2 and Ke1, Ke2. E1 nothing but here Hc by lambda 1, Hc by lambda 2, Hc mutually cancel. Then Ke1 nothing but p square by 2m, 1.5 whole square p square by 2m. Okay, this is also mutually cancelled. Therefore lambda 2 by lambda 1, so this will become here 1 by 1.5 whole square means 1 by 2.25. Okay, so this is the answer. Or to avoid the fractional value, so this value is multiplied with suitable integer, maybe with 2 or 3 or 4, so on. By multiplying with 2 also will get 4.5 something, so fractional value. By multiplying with 3 also fraction value, but multiplying with 4 will get whole number. Lambda 2 by lambda 1 is equals to 1 by 2.25 into 4 by 4, that is equals to 4 by 9. 4 by lambda 2 by lambda 1, or lambda 2 is equals to 4 by 9 lambda 1. So this is the answer present in the option. Clear? That's all for this video. You have to practice numericals based on these formulas. Okay. In the next video, we will do bits for remaining topic of atomic structure. Okay. Thank you for watching this video. Thanks a lot.